Good morning, everyone.
Good morning, sir.
Morning. Okay. So we'll start with pseudo force, something called a non-inertial reference frame we'll talk about. All right. So let's say we have got two reference frames. One is reference frame O, another reference frame O prime. There's a particle P here. It's a, this reference. This is R2 bar. This is R1 bar. And this is R0 bar. Right. Now, if I see the triangle R0 plus R2 is R1. R0 plus R2 bar is R1 bar. So R2 bar is R1 bar minus R0 bar. All I've done is I've drawn the position vectors, seen the triangle, written the triangle equation from the triangle diagram, vector equation for the triangle diagram, and then I've rearranged it. R2 bar is equal to R1 bar minus R0 bar. If I differentiate, I'll get A2 bar is equal to A0, A1 bar minus A0 bar. If I differentiate twice, if I now multiply with mass, see, I'm going to show you something mathematical and then we'll talk about its physical significance in a minute. If I multiply with mass now, I'll get MA2 bar is equal to MA1 bar minus MA0 bar. If I see what is MA1 bar, MA1 bar is nothing but the effect of the force. I mean, A1 is the effect of the force, so MA1 is the cause force acting on the particle in reference frame 1 or O1, 1, 2. In reference frame O, forces acting on it are F bar minus MA0 bar. If I talk of MA2, and I think of this as a force acting on the particle with respect to 2. With respect to reference frame 2, F prime is equal to F bar minus MA0 bar. So if you see, this force is altered. There's a value which is subtracted from this force to get this force, to get F bar, F prime. Alright, so we are not getting the forces to be the same. We are getting a factor which is being subtracted from force in the reference frame 1, where A0 is acceleration of the reference frame O prime with respect to O. Alright. What I mean to say is, if forces are F acting on this particle with respect to reference frame 1, which is MA1, and acceleration of the reference frame 2 is A0 with respect to 1, then F prime, which is forces on particle with respect to the reference frame 2, which is prime reference frame, is not same, but you're getting a factor which is being subtracted from the force F, which is MA1. That's what mathematically it's seen. Let's understand its physical significance. Frame which is accelerating is called a non-inertial reference frame. A frame which is not accelerating, that is a frame which is moving with constant velocity or it's moving with at rest with respect to ground, or a ground is a inertial reference frame. but whereas an accelerating frame is called as a non-inertial reference frame. Assume let us say I've got a truck, frictionless floor, mass m is kept on it. This truck is traveling towards right with an acceleration of a naught. All right. With respect to ground, if I observe this mass, what are the forces acting on it? If I draw the FBD of the mass, I've got normal reaction, I've got m naught g, and that's it. No horizontal force, nothing. So it will always remain at rest. N will counterbalance mg, and will remain this particle will remain at rest with respect to ground. But with respect to car, if I draw this FBD, with respect to car, okay, FBD and MED are zero, so acceleration is zero over here. So it makes complete sense. No force acting, no acceleration resulting. No cause, no effect. But then if I draw the FBD and MED with respect to this reference frame, which is accelerating with respect to car or with respect to truck, what I see, this is the FBD of this one, all the forces acting on it. But in addition, the MAD would be acceleration of the particle with respect to the car would be towards left. So I will have an acceleration whereas no force acting on it. There is no force acting on it, but still there is an acceleration resulting in this reference frame. That means Newton's law is violated. All right, so Newton's law is not applied in non-inertial reference frame. You cannot apply Newton's law in non-inertial reference frame because you are getting an effect without a cause. చూడండి ఇక్కడ force ఏం horizontal acceleration horizontal direction ఏం force లేదు, but still you have got an acceleration in the horizontal direction towards left, and this is because reference frame is accelerating. Reference frame towards right accelerating అవుతుంది కాబట్టి mass will appear to go towards left. With respect to the reference frame A naught car, which is traveling towards right with A naught, mass will appear to go towards left with A naught. But if I draw the FBD, there is no horizontal force acting on the particle. So Newton's law is violated here. So what we do to explain this effect, we say there is a force acting on it in such a reference frame which is equal to mass times acceleration of the reference frame and opposite to direction of reference acceleration of the reference frame. When we solve some problems, you'll get to know, you'll get hold of it. But as of now, you understand there is a violation of Newton's law. To explain that, to apply Newton's law, to make a correction in that, not exactly correction, but we are just making a mathematical term added to it so that we can solve some problems, so that we can apply Newton's equation in this reference frame, where actually it's violated. So Newton's law is violated in non-inertial reference frame. It is not applied in non-inertial reference frames. All right. So okay. So with respect to ground, cause and effect matched. But with respect to the truck, there is no cause, but there is an effect. To explain this effect, we say there is a cause of ma naught on the particle, which is nothing but it doesn't actually have a real cause. It's not a real cause. It is just a false term. It's just a mathematical term added to the equation to explain this effect. That's why it's called a pseudo force or a fictitious force or a false force or inertial force. All right. So this force doesn't actually exist. That is why it's called a false force. All the real forces will have an action reaction pair, but a pseudo force will not have an action reaction pair. You cannot say reaction of pseudo force is on the truck. No. Pseudo force does not have a reaction. It does not have action reaction pair. It is just a mathematical term added so as to satisfy the Newton's equation. All right. ఇప్పుడు చూడండి. Now let's say I've got the same block placed over here. And this accelerating towards right. So if I draw the FBD now, I'll have one normal reaction like this N1, M0G, another normal reaction like this N0, and acceleration A0. From ground frame, I've got a force towards right, resulting in an acceleration towards right. So it makes complete sense. All right, so Newton's law is valid because I've got a cause and effect. Normal reaction is acting because which is resulting in an acceleration, horizontal acceleration towards right. If I draw the FBD again, if I think of this FBD again from this reference frame, where you don't have an acceleration now. You have a cause, but you don't have an effect. Right? Normal reaction on the N1 on the M0G on the, but acceleration ledu with respect to the car. Because it's moving along with the car, acceleration of this block with respect to the car is zero. So acceleration is zero. So you have a cause, but you don't have an effect. Again, Newton's law is violated. So we say there is a counterbalance, there is a force which is counterbalances normal reaction and which is equal to ma naught mass into acceleration of the reference frame and acting opposite the direction of reference frame. So pseudo force always acts in the direction opposite to the direction of acceleration of the reference frame and is equal to mass times acceleration. Is it clear, students? Pseudo force is equal to mass times acceleration and always acts in the direction opposite to the direction of acceleration of the reference frame. Is it clear, students?
Yes, sir.
Yes, sir.
All right. Now let us see some situations. I've got a block. I've got a person here moving with an acceleration of g by 2. And this is on ground, this mass block M, mass of the block is M0. Acceleration of the person over here is g by 2 towards right. What is the pseudo force acting on it? If I consider this block with respect to the reference frame attached to the man, what is the pseudo force acting on the block?
I'm not into G by 2.
Perfect. M0 into g by 2 in which direction? Opposite to the direction of the accelerated frame. Acceleration is towards right, pseudo force will be towards left. So I'll have normal reaction like this, M0G like this, and mg by 2 like this. So this is the FBD with respect to this person. But with respect to ground, what is the FBD? I'll just have normal reaction and M0G with respect to ground. With respect to this is the FBD. With respect to ground, there is no acceleration, no cause, no effect. But with respect to this person, there is an effect, which is g by 2. Acceleration is towards left with respect to the person, which is caused by the pseudo force mg by 2. So mg by 2 by m will give me g by 2. So this is the cause of this effect. This effect is because of the relative motion. G by 2 relative motion will వచ్చింది because I'm moving towards right, block is moving towards left with G by 2 because I'm moving with G by 2, block is appearing to move towards left with G by 2. But there is no real cause resulting in that effect. So I say there is a pseudo force which is resulting in that effect, and which the pseudo force is equal to mass times acceleration of the reference frame oppositely directed to the acceleration of the reference frame. All right. One more. Remember one thing, students. Any problem which can be solved using pseudo force can be solved using non inertial reference frame to solve చేయొచ్చు అంటే నాన్ షెల్ frame తో కూడా solve చేయొచ్చు. With you choosing any reference frame, you can solve any problem. But whenever a accelerated reference frame is you come across an accelerated reference frame, better go for pseudo force approach. I'll show you both the approaches, but you see pseudo force approach is more convenient than the ground frame approach. All right, inertial frame లో కంటే non-inertial frame is much easier to tackle. Equations are simpler. ఒకటే equation లో వచ్చేస్తుంది. Equations will be shorter. I mean steps తక్కువ ఉంటాయి. So equations are fast. Process is faster in non-inertial reference frame compared to the ground frame, inertial frame. All right, here I've got string log of mass m naught, and this is going upward with an acceleration a naught. All right. So with respect to ground, let us solve it with respect to ground first. With respect to ground, what is the FBD? Tension m naught g, acceleration MAD. All right, this is from ground. This is a FBD and MAD. Both together, I've got complete picture of the block. So I can write the equation now. The equation would be T minus m naught g equal to m into A. Now look at this equation, students. It is cause is equal to effect. Net force is equal to mass into acceleration. Now let us do the same thing with respect to this reference frame, lift. Lift నుంచి సాల్వ్ చేస్తే గ్రౌండ్ ఇది లిఫ్ట్. లిఫ్ట్ నుంచి సాల్వ్ చేస్తే ఎలా ఉంటుంది? I've got tension. All the real forces will be existing even in the non-inertial reference frame, but acceleration is zero. But there will be pseudo force acting on it. Pseudo force will be
Downward.
m naught into a naught, opposite direction of a naught. A naught పైకి ఉంది, m naught into కిందకు ఉంటుంది. Now I'll write equation now. Now my FBD and MAD are complete. Right? FBD is complete, MAD is complete. Acceleration is zero here, but here there is an acceleration. So how would I write this equation now? I'll write T minus m naught g plus m a naught, m naught a naught is equal to zero. Look at this, students. రెండు equations are mathematically equivalent, but they are physically different. Physical significance different ఉంది. ఇక్కడ net force is equal to mass into acceleration. Net force is equal to mass into acceleration. Here acceleration is zero, but net force is resulting in no acceleration. No, net force is zero ఇక్కడ equilibrium లో ఉంది particle. But here it's not in equilibrium. There is net force, because of which there is an acceleration. But if I bring this mg over here, if I bring this towards right, I'll get t is equal to m into g plus a. From both the cases, from both the scenarios, from both the frames, I get the tension as m into g plus a, m into g plus a. But the step, the physical significance of the step which I've written is different. Here I've written cause is t minus mg, which is resulting in an acceleration a naught. But here the cause is t minus m naught g plus ma, which is resulting in no acceleration. The particle is in equilibrium in this reference frame, but whereas the particle is accelerating in this reference frame. Mathematically equivalent, but physically different. All right, this is what you have to understand while solving problems. This is much easier, I say, because all you have to do is stand in the reference frame, apply pseudo force, write the equation. All right, we will see which one is easier eventually. But all right, is it clear, students? Is this procedure clear from ground frame and from left frame, from inertial frame and non-inertial frame?
Yes, sir.
Okay. Now let us say, students, this is going towards, it's going downwards with an acceleration a naught. Now can you tell me what's the tension in the string? So acceleration is reversed here. And pseudo force is reversed here. So it would be m naught g minus t is equal to m naught into m into a naught. So T is equal to m into g minus a naught. Over here, T plus m a naught minus mg is equal to 0. T plus m a naught minus mg is equal to 0. So I'll have T is equal to g minus a naught, m into g minus a naught. Is it clear, students? Now what I do, let this acceleration be equal to g. And let's see what is happening to tension. If this is equal to g, tension is becoming 0. Right? From this case, from ground frame or this frame, my real forces should result in the same value. My values cannot change. My results cannot change if I change the reference frame. All right. So results have to be same. So tension is 0 in this case, ground frame. Tension 0 the g minus 0. Equal to g minus a naught is 0. But here the equation we have written is using pseudo force. Here we have written only using real forces. ఇక్కడ రియల్ ఫోర్స్ ఉంటుంది సూడో ఫోర్స్ ఉంటుంది ఇంకా ఎఫెక్ట్ లో యాక్సిలరేషన్ విత్ రెస్పెక్ట్ టు రిఫరెన్స్ ఫ్రేమ్ ఉంటుంది on RHS it is 0 because acceleration of the block with respect to the frame is 0, so m into 0 we got. All right, now if I move this lift with an acceleration of g downward, tension becomes 0. That means if I move this block, if I hold this block and keep it over here, it will remain there itself without the requirement of tension. Tension is not required for the particle to remain at that place. That's what it means. Tension is 0 ante tension is not required at all for the particle to remain at that place. ఇప్పుడు ఈ స్ట్రింగ్ కట్ చేస్తే కూడా పార్టికల్ అక్కడే ఉంటుంది. పార్టికల్ ని తీసి మళ్ళీ ఇక్కడ పెడితే, if I hold the particle and keep it here, when in the lift it will remain there itself. So with respect to me, the particle always remain at rest with respect to me. That's what it's saying. T is equal to 0 and it's going to be at rest with respect to the lift. With respect to ground, what is happening? It's coming down with g. Lift is coming down with g, particle is coming down with g. So both are together coming down with g. So relative acceleration is 0. That is why this particle is at rest with respect to the reference frame. All right?
Yes, sir. Yes, sir.
Okay, now let's find out normal reaction. A naught to pike on the lift. Right? This particle is of mass m. So with respect to ground frame, I'll draw the FBD and MAD. Normal reaction, mg, A naught. With respect to lift frame, I just have normal reaction, mg, and additionally ma naught, pseudo force. And acceleration is 0 because it is at rest with respect to the lift. Okay, now I write the equations. I write n minus mg is equal to ma naught. So n is equal to m into g plus a naught. I get normal reaction as g plus a naught. But now over here, if I write the equations here, I'll get n minus mg plus ma equal to 0. Physically, how I read these equations is different, students. Mathematically, they are same. I'll get the same answer. But if I ask you what is the physical significance and the difference between these two equations, there is hell lot of difference. I'll get the normal reaction as same, but the equation which I read over here is different. It's in equilibrium here. Net force is resulting in no effect. So net force is 0. So acceleration is 0, effect is 0, net force is 0. So it's in equilibrium. But over here, it's not in equilibrium. Net force is resulting in some acceleration. But normal reaction is turning out to be m into g plus a, numerically m into g plus a. So normal reaction, because the force is independent of the reference frame I choose. In Galilean mechanics, Galilean relativity, don't worry about the word. Don't worry about the word. We'll talk about such words later. Normal reaction turns out to be the same, but the physical meaning of this equation is different. That's what I want to insist. E equation meaning different, but mathematically they are same. All right. Now let us say this goes down with G. Now what happens? Or G by 2, let's say. It goes down with G by 2. Now how will I write the equations to be? Now can you tell me what the normal reaction is? ఇక్కడ G by 2 ఉంటుంది. So I'll have mg minus normal reaction is equal to m into G by 2. So normal reaction is equal to mg by 2. And over here, how would I write this equation? I will have pseudo force, which is acting upwards. And the pseudo force will be equal to mass into acceleration of the reference frame, directed opposite to the direction of the reference frame. Acceleration of the reference frame. I repeat, pseudo force is mass times the acceleration of the reference frame, directed opposite to the direction of the acceleration of the reference frame. Reference frame is going downwards, pseudo force will be upwards. So I'll write n plus mg by 2 minus mg equal to 0. Net force is equal to mass into acceleration. Acceleration is 0. So n is equal to mg by 2. So if I keep a weighing machine here, my weight normal reaction, it measures normal reaction, students. A weighing machine measures normal reaction. A spring balance measures tension. If I keep a weighing machine there, my weighing machine will not read mg, but it will read mg by 2. A weighing machine reads normal reaction. A spring balance reads tension in the string. All right. So always remember, a weighing machine will not read your weight. It will not read your mass, exact mass into G. It will read the weight. Weight is nothing but the normal reaction exerted by the particle on the weighing machine. So weighing machine measures normal reaction, not mg. When it is on ground, it measures mg, but it actually measures normal reaction, but not mg. It so happens that on ground, normal reaction is equal to mg, so it gives mg. So we say weight mg only, but weight is not actually mg. That's wrong to say weight is mg. Weight is actually normal reaction measured by the weighing machine. So normal reaction measured is weight. Weight is not mg. Weight is mg only the case when it's on ground where n is equal to mg. Excuse me. All right, I'll give you acceleration, students. You tell me what's the weight or weight of the particle. It is going up with an acceleration of g by 2. Can you tell me what is the normal reaction measured by the weighing machine? Students, use pen and paper and tell me. It's going up with g by 2. So with respect to ground, I'll write n minus mg is equal to mass into acceleration, which is g by 2. This is my normal reaction with respect to ground. But with respect to this lift, I'll have normal reaction in mg as usual. As in the case of ground, real forces are always there. But I'll have an additional pseudo force, which is mass times acceleration of the reference frame, oppositely directed to the reference frame. Acceleration of the reference frame. Sorry. Oppositely directed to the acceleration of the reference frame. So I'll have n minus mg by 2 plus mg equal to 0. So can you tell me what mg, n is from both the equations? Students, FBD lo difference ఉంటుంది, MAD lo difference ఉంటుంది. Once you draw the FBD and MAD correctly, all you have to do is write F is equal to MA. So before you start solving the equation, okay, Bhavna has an answer. Yes, Bhavna, that's right. That's right. That's absolutely right. All right. So the strategy to solve any problem is choose a reference frame. Is it a ground frame or an accelerated reference frame? Once you choose a reference frame, draw the FBD with respect to that frame. That means you will have all the real forces. If that is an accelerated reference frame, you will have an additional pseudo force in your FBD. But your MAD will be different in both the cases. Your MAD acceleration diagram will be different with respect to ground frame, with respect to accelerated frame. Over here, with respect to ground, the particle is going up with g by 2. But with respect to the lift, particle is not going at all, not moving at all. So acceleration is 0. So your FBD and MAD are correct. All remains is to write F is equal to MA. Net force is equal to mass into acceleration. Net force is equal to mass into acceleration. Any problem can be solved in these 3 steps. First step, choose a reference frame, inertial or non-inertial. Then draw the FBD in that reference frame and write F is equal to MA in that reference frame. That's it. If that is an accelerated reference frame, be careful that you don't miss the pseudo force. You will have all the real forces. In addition to those forces, you will have an additional pseudo force, which does not have a reaction. All right. All the real forces have action reaction pair, but a pseudo force does not have an action reaction pair. It is just a mathematical term added so as to solve a problem. All right. So as to make the equations, Newton's equations work in a non-initial difference frame. All right. Now let's consider another case. I've got a pendulum. This car is moving towards right with an acceleration a naught. All right. Let us understand this with respect to ground, with respect to car. Why do we have a deflection over there? What does the deflection mean? Like, why is the deflection resulted? See, మీరు ఆలోచించవచ్చు కదా, if you are going in a train or a car which suddenly accelerates, car అనుకుంటే or bus అనుకుంటే, which suddenly accelerates, you have something, this will tend to move backward, right? Let's say I'm in a car, I'm in a bus suddenly accelerates, I tend to move backward, right? Why? That is because of the pseudo force which is acting on me and which is making me push backward. With respect to ground, ఎలా చెప్తాను? That's inertia of rest. I was at rest. This is me sitting here. If this suddenly accelerates, I tend to move behind because pseudo force acts on it, on me, which is mass times acceleration and directed opposite to the acceleration of the reference frame. That is my bus. With respect to ground చూస్తే ఏమవుతుంది? There is no force acting on me. So I tend to remain over there itself and the bus moves forward, because of which I seem to go backward. All right. Such cases నేను పంపిస్తాను for you to read. But as of now, let's solve some problems. Okay, let's understand this one. If this were not accelerating, I would have this vertically hanging. Do you all agree with that? If this were not accelerating, if a naught were 0, it would hang vertically. But if a naught is not equal to 0, this will tend to move backward and have a deflection of theta naught. With respect to ground చూద్దాము. See how the equations are a little tricky in with respect to ground. And that is why I suggest that you go with respect to accelerated reference frame. Whenever you have an accelerated reference frame, go with a pseudo force approach. That's easier. I'll show you why. Easier in the sense it's just a little convenient. 1 or 2 steps are more convenient than the other ground frame. From ground frame, I've got tension T in the string. Mg is downward. Resultant of these two is making it move towards right. So acceleration is towards right, effective is towards right. All right. So I can write this is theta, this is theta, t sine theta is equal to mass into acceleration, t cos theta is equal to m into g, sorry, t cos theta minus mg equal to 0. There's a difference, students. T sine theta is equal to mass into acceleration ante this force is resulting in this acceleration. T cos theta minus mg ante net force is equal to 0 acceleration. There's no vertical acceleration. With respect to ground, there's only horizontal acceleration. Vertical acceleration ledu. So T cos theta is equal to mg mathematically. If I divide these two equations, m gets cancelled out, t gets cancelled out, and have tan theta is equal to a by g. So theta is tan inverse a by g. Fine, this is fine. But now let's go with the lift reference frame, car's reference frame, non-initial reference frame. Now in this reference frame, I'll have tension T, real forces will as it is be there. In addition to this, I'll have a pseudo force, which is mass times acceleration, oppositely directed to the acceleration of the reference frame. All right, now let's write the equations. I'll have this as theta, theta naught, T sine theta naught minus ma naught equal to 0, T cos theta naught minus mg equal to 0. Equations do not mean the same. They are resulting in the same results. They are resulting in same values, but they do not mean the same. That's very important, students. కొన్ని tricky questions లో ఇలాంటి objective లో multi correct లో ఇలాంటి statement రావచ్చు. That equation over here, it means it's in equilibrium. Net force is equal to mass into 0. Acceleration is 0 with respect to this reference frame. MAD. MAD చూస్తే acceleration is 0. But over here, net force is resulting in acceleration. Here, net force is resulting in 0 acceleration. Net force is equal to 0, mass into ay, vertical acceleration is 0, but horizontal force is net force equal to mass into horizontal acceleration. But over here, horizontal force is resulting in no acceleration, horizontal force, vertical force are resulting in no acceleration. So it's in horizontal equilibrium, it's in vertical equilibrium. So it's in equilibrium here, it's not in equilibrium here. It's in horizontal, vertical equilibrium here, that's fine. But horizontally, it's not in equilibrium. And this MA term, when it comes to left, it's a pseudo force. See, here it's mass into acceleration, it's the effect of the cause. But here, it's a cause here, it's a pseudo cause. That's a force, pseudo force there, which is resulting in no acceleration, because of which the particle is in equilibrium. All right, so we are adding an additional term so as to use these equations, Newton's equations, so as to apply these equations to the motion of the particle. All right, so there's a difference. I repeat again and again. Here, net force is resulting in mass into acceleration, but here net force, which is with an additional term of pseudo force, is resulting in no acceleration. So it's an equilibrium equation. Both are equivalent. నేను రైట్ సైడ్ దీనికి రైట్ సైడ్ తీసుకెళ్తే రెండు ఈక్వేషన్ సేమ్ వస్తాయి. T sin theta is equal to ma, T sin theta is equal to ma, but they mean different over here and here. All right, I hope you understand this point. So I get tan theta is equal to a naught by g. Whether it's from here or here, you get theta is same. All right, now, all right, so I'll erase this. There's a car in which this is 45 degrees. Determine the acceleration of the car. Do not go by formula, go by equations. ఆ ఫార్ములా గుర్తుపెట్టుకొని టైం ఇన్వర్స్ a by g చేయకండి. All right. So how do I do it? How do I find the acceleration of this one? I'll go with, I told you, let's go with choose a reference frame first. So I'll choose non-inertial reference frame to solve the problem. I'll choose this frame. So with respect to that frame, which is car, I'll have T mg ma, pseudo forces. This is pseudo force, this is a real force and real force. And this is 45 degrees. So T by root 2 minus ma naught is equal to 0. T by root 2 is equal to minus mg equal to 0. I equate these two. I divide these two, m gets cancelled out, t gets cancelled out. A naught is equal to g. So if it moves with an acceleration g, I'll have mg and mg root 2 diagonally, which is counterbalanced by t. All right. Is it okay, students? Is it clear how I got A is equal to G?
No, sir.
No? All right. See, this is 45 degrees. Pseudo force here, real force mg here, tension real force here. All right. I take the component now. T cos 45 minus mg equal to 0. Right? T cos 45 minus mg equal to 0 because there is no vertical acceleration. With
Yes,
respect to
sir.
the car, yeah. So horizontal acceleration, I'll write T sine 45, T sine 45, which is horizontal component, minus m naught equal to 0. What is this m naught here? It is not mass into acceleration, it's pseudo force. It is not acceleration of the particle. It is acceleration. Actually, a naught is actually the reference frame, where m naught is a pseudo force acting on the particle. So T sine 45 minus m naught equal to 0. This implies cos 45 is 1 by root 2, T by root 2 is equal to mg, T by root 2 equal to ma. I divide these two, this gets cancelled out, m gets cancelled out, g, a is equal to g. See, I got a naught is equal to g. That means if I have an m got cancelled out, that means if a particle is traveling with some acceleration, I'll have theta irrespective of m. Same theta irrespective of m. M 1 kg unna, 2 kg unna, 3 kg unna, any kg unna, my angle is going to be same. It depends only on the acceleration of the reference frame, which is tan inverse a by g. In this case, it's 45. In this case, when a is equal to g, it's 45. I did not use the formula tan inverse a by g. It's confused. It's misleading sometimes. మీరు ఫార్ములా ఎప్పుడైనా ఇది తీటా ఇస్తే అప్పుడు కన్ఫ్యూజ్ అయిపోతారు. Let's see. For example, go with the equation, students. Don't go by end result formulae. That's very wrong. ఇది 30 degrees ఇస్తారు. I have to find the acceleration of the reference frame if the equilibrium angle of the bob is 30 degrees with the horizontal, not with the vertical. ఎలా చేస్తాను? This is 30 degrees. So this is 30 degrees. This is T. This is mg. Is my FBD complete, students? Is my FBD complete? No, because there
T,
is a
sir.
pseudo-force. Pseudo-force draw చేయాలి. Pseudo-force draw చేస్తేనే complete అవుతుంది because it's an accelerated reference frame.
Tension, sir. Tension.
Tension T, right? Tension T. Is it complete now?
No, sir.
Pseudo-force draw చేయాలి.
Pseudo-force.
Ma naught. Why is it towards left? Because acceleration of the reference frame is towards right. Pseudo-force is towards left. Now I'll take the component. T cos 30, which is T root 3 by 2, is equal to, sorry, not equal to, minus ma naught equal to 0. I can write equal to ma, but that means different. But when I write T, this minus this equal to 0, it means net force is equal to 0, mass into 0 acceleration. All right. Now if I write vertically, T sine 30 minus mg equal to 0. So I'll have T root 3 by 2 equal to ma naught, T by 2 equal to mg. I divide these two, T by 2 gets cancelled out, m gets cancelled out, a naught is equal to g root 3.
Yes, sir.
All right. See, if I were to use a tan inverse A by G, I'll get a wrong answer because tan inverse A by G derive చేసినప్పుడు ఇది theta తీసుకున్నాం. కానీ ఇప్పుడు నేను ఇది ఇచ్చాను theta. So this is 60 degrees. So A naught is equal to tan inverse A by G అంటే tan theta is root 3. A is equal to G tan theta. So G root 3. G root 3 వస్తుంది. But formulas are sometimes see మీరు 2 years చేసినప్పుడు చాలా equations you will come across so many formulae. If you don't understand the derivation of the formula, application will be misleading. I mean, the formula will mislead you in the case of some tricky problems. All right. So always understand how the formula is derived. Okay. Now let us do one more thing. I've got an inclined plane, 30 degrees. There's a car sliding down with an acceleration of g sine theta, which is g by 2. All right. Now there's a bob here. If this were not accelerating, if I were to just hold the car, that will be vertical. అది vertical ఉంటుంది కదా. If this is not accelerating, one bob will be hanging vertically, right?
Yes, sir.
But now if this is accelerating, I'll have a pseudo force on that particle. In what direction will I have a pseudo force? Up the incline, because acceleration is down the incline, pseudo force will be up the incline. And that pseudo force will be, let's say, theta ఇలా ఉంది. Let's draw the FBD now. Look at this. I have to find out theta ultimately. All right. This is mg by 2. This is how much? Mg cos. I've got mg, right? This way is mg. This is mg by 2. Okay, now look at the students. What is the component of mg along this horizontal? ఇది theta 30 degrees అంటే ఇది 30 అంటే ఇది theta కనుక్కోవాలి. ఇది 30. So mg sin 30, right? Mg sin 30 is my component.
Yes, sir.
So I'll have net force would be one is tension, pseudo force mg. I'll take component along the inclined plane, parallel to the plane. So I'll have t plus mg by 2 minus mg by 2 equal to 0. Not t, it's t sin theta. Theta kada t sin theta. Sorry. T sin theta plus mg by 2 minus mg by 2 is equal to 0. This is one equation. An anti-equation along the parallel to the plane. ఇప్పుడు perpendicular plane చూద్దాము. I'll have t cos theta minus mg root 3 by 2 equal to 0. Look at this. T sin theta is turning out to be 0 because this is getting cancelled out. So either theta is 0 or t is 0. But if you look at this equation, t cos theta is equal to mg root 3 by 2. So t is equal to mg root 3 by 2. Here, even if theta is 0, t cannot be 0. T is non-zero here. Right? If I divide these two equations, I'll get tan theta is equal to 0, theta equal to 0. That means in an accelerating in an accelerating car which is sliding down with g by 2, the bob will be perpendicular to the ceiling roof. So it will hang vertically in that field. Vertical అంటే అది vertical కాదు, ఈ vertical కాదు. Now it's vertical now tilted. Now vertical నార్మల్ వర్టికల్ ఇలా ఉండే కదా, కార్ కింద ఉండే, కార్ ఇలా అయినప్పుడు దట్ వర్టికల్ ఇస్ నాట్ టిల్టెడ్, particle will stay in equilibrium over here. All right, so that's the equilibrium position of the particle. All right, now
Yes,
the
sir.
question is what happens if I move this upward with g by 2? ఇప్పుడు ఏమవుతుంది? Will it move, deflect in this direction or this direction, upward or downward?
Downwards, sir.
Downward, right? Because in this reference frame, pseudo force will act downward. So pseudo force equation rasi, FBD rasi, MAD is zero, acceleration is zero, mass acceleration diagram is simple, but FBD is little. FBD clear గా డ్రా చేసి కాంపోనెంట్స్ తీసుకుంటే you get the answer. So let theta be the deflection. This is mg by 2. This is mg. This is 30. Required to find theta naught. All right, let's find this theta naught and then close it here. Tomorrow we're going to do pseudo force problems, critical problems on pseudo force and spring force. All right, students, critical problems చేద్దాము. Today we was just an introduction, but tomorrow we'll see how to apply pseudo force in difficult kind of tricky problems. All right, tough problems. All right, so will you try this one? Tension T, this is theta, T cos theta, mg cos 30, mg sin 30. So this will be mg root 3 by 2. This will be mg by 2. So I've taken the component of mg also. So that is T sin theta minus mg by 2 pseudo force minus mg by 2 component of gravitational force equal to 0. And T cos theta minus mg root 3 by 2 equal to 0. Again, I take it to the right side, I get mg. Take it to the right side, I get mg root 3 by 2. I divide these two equations, T gets cancelled out, M gets cancelled out, tan theta is equal to, G also gets cancelled out, 2 by root 3. So theta is equal to tan inverse of 2 by root 3. Have you understood this, students?
Yes, sir.
Now your homework is, it's not going with g by 2, but let's say it's going with acceleration a naught. Then find theta. All right, so we'll have tan inverse of something a naught by g plus a naught, something like that. A sin theta, cos theta components వస్తాయి. Right? And if you want, you can take this as a convenient angle. 45 తీసుకుందాము. All right, will you try this?
Yes, sir.
All right, good. So let's stop here. Tomorrow we'll do some tricky problems on pseudo forces. Today I will send some illustrations on pseudo forces. All right, and take questions, inka solution. Question solution rendu pampistanu. I'll send some 3 or 4 questions. You please go through those questions before you come to the class tomorrow. All right, 3 or 4 questions pampistanu. Maybe maximum like 2 or 3 maybe. I'll send some questions to you. You just go through the question and the solution. All right, we'll discuss this again tomorrow, but tomorrow we'll be dealing with some good problems.
Okay, sir.
Okay,
All
sir.
right then. Have a great day, students. Bye, everyone. I hope you understood. See, students, ఏదైనా doubt ఉంటే ఆపండి. It's very important concept. Pseudo force is going to, we are going to apply this in throughout mechanics, rotational dynamics, fluid mechanics వరకు మేము అప్లై చేస్తూనే ఉంటాము మెకానిక్స్ లో. So please don't be hesitant to ask any doubt. ఏ డౌట్ ఉన్నా అడగండి. All right. If you want me
Okay.
to put it again differently, I'll put it. Or if you want me to repeat again, I'll do it. Repeat again and again, I'll do it. But it's very important that you understand the concept. All right. So then, bye everyone.
Bye.